Okay, so function operations. What are the basic four function operations? What's the four basic math operations?
Add, subtract, multiply, divide.
Yeah, add, subtract, multiply, divide, right? So for function operations, we're basically going to do the same thing for this thing. And there's basically two different ways you can write these out. You can either have f of x plus g of x for two functions, or you could have f plus g of x. For subtraction, pretty much the same thing. Okay. Now, as far as what we're doing, this will be kind of a good review because if you're working with the different functions in this part of it, for addition and subtraction, the only thing you're really going to do is you're going to combine like terms. All right, if we're doing f of x times g of x, it's multiplication. In that sense, mostly, you might have some distributive property, but a lot of it's going to be just doing the fold method. And division, f of x divided by g of x could look like that. This one doesn't really look a whole lot different. It could look something like that. And division is actually not division. It's actually factoring. So you're going to factor the numerator and the denominator, and then you're going to cancel if it's possible. So addition, subtraction, they're what they are. Multiplication, it is what it is. But division is actually, and a lot of times when we do stuff, it's not actually even division. In this case, again, it's division, but it's really more factoring and canceling than it is anything else when you go through these parts. FOIL multiplication, most likely. You might, depending on the problem, but probably I would say 90% of the problems, 95% of the problems you'll be doing some version of the FOIL method. Okay. And if they happen to, and this will be kind of a little bit of a review, but I think also a little bit of a preview as well, because we haven't talked about domain and range in a while, so this will be a good review. But we're also getting ready to talk more about domain and range and some topics that's coming up soon. That when we're talking about all these, with all these functions, the domain is going to be basically all real numbers. But you're going to exclude the denominator equal to 0. So it's all real numbers. The exception is that you're going to exclude. So basically, if you got a division problem, you're going to have to exclude this denominator equal to 0. Okay. Now, one other thing that might possibly pop up with these, since we're talking about rationals, let's actually just say square roots, because third roots are okay. They may throw a few square roots at you. Square roots, for anything square roots wise, you're going to have to make sure that it's greater than or equal to 0. I just don't know how many square roots we'll get in there, but we're going to kind of mix it in just a little bit. Okay, so your domain is all real numbers. The only exceptions you're looking for is if you have a fraction, you've got to exclude the denominator equal to 0. And then the second thing you've got to look for is if you have square roots, it has to be greater than or equal to 0. Third roots are okay, because again, third roots you can have positive, you can have negative numbers. Square roots, remember, if we square root a negative number, we might give them something imaginary, and right now we don't want anything imaginary, so we're going to say, all right, just so we don't get anything imaginary, anything square root wise, we need to make sure it's greater than or equal to 0. Third roots are fine, but square roots have to be greater than 0. Okay, so for the first example, I think we may just go ahead and do, I guess we can do all four of these. We may do addition, subtraction, multiplication, division. We'll kind of mix it in and do what we can do here. Well, actually, will be a part A in here when we get through this one. So, okay, so for example one, we're going to do all four parts. For part A, we're going to do F plus G. So that's going to be 2x squared plus 8 plus x minus 3. And remember, with addition and subtraction, you're just combining like terms. So this should be the easy parts to go through. The only thing you have to be careful of is, which really doesn't impact this one, is there's a 1 that's here. So that's 2x squared. And they will want these answers in descending order in standard form. So you've got 2x squared, you've got plus the x, which we didn't have to combine it with anything, so that was nice. And then 8 minus 3 would be 8 plus 5. All right, if they were asked for a domain, there was no fractions, there were no square roots. So in this case, domain would basically be all real numbers. Okay, and for these, we're going to make a little bit of a shortcut here for this one. If the answer is all real numbers, do a double-legged R, and that's all real numbers. That was a shortcut that we learned in college when we started talking about domain and range for those. So if it's all real numbers, just do a double-legged R, and that's the shortcut for saying all real numbers. Just do this and then leave a little space, and then do that.
Okay.
Yeah. Or you can do the R and then just do that. Yeah. All right, for B, let's do F minus G. Okay, and again, the subtraction is the one that it's not hard, but you have to be careful. It's kind of like some of the stuff we were doing on Friday. It's not hard, it's just tedious. This is another one of those that you've got to be careful because it's f of x minus g of x. And in that case, you do want to kind of have that one with the parentheses around the second part of it. Technically, that's what we should have done back here, which with addition, it doesn't do anything. But subtraction, it does do something because that's going to be 2x squared plus 8. And remember, the minus in front means you've got to change this sign. You've also got to change that sign. Okay, so that's 2x squared minus x. In this case, we've got 8 plus 3. So that would get 11. Okay. And again, domain in that case would be all real numbers. No fractions, no square roots. So then we're good to go. All right, for multiplication. Again, this is going to be full method. That it's 2x squared plus 8 times x minus 3. All right, so we go 2x squared times x, that is 2x to the third. 2x squared times negative 3, that's a negative 6x squared. On the bottom, 8 times x is 8x. 8 times negative 3 is a negative 24. And the good news on this one was the way our problem was set up, there's no combining like terms here because all these are different terms, different power terms. So in that case, that one is your answer. And again, no fractions, no radicals. So domain in that case would still be all real numbers. Sure. Okay.
Is today's next
All right, so let's go f of x divided by g of x. All right, so for this one, that is 2x squared plus 8 divided by x minus 3. And the only little bit of factoring you can do on this one would be dividing a 2 out of the top. And with that, nothing cancels. So that problem, that's it. That is your answer. Because there's really nothing else there that you can do to it. That's the bad thing is with division, a lot of times, if there's nothing that like simplify, if there's no cancellation, if there's no factoring that works, a lot of times that's just your answer. And it's honestly about a 50-50 split. There's half the problems you'll get that you don't do anything with it, and then the other half will be that they'll factor, and then you can do something with it. And we'll show you one here in a minute that you actually can factor for this part. So. All right, now in this case, your answer is not going to be all real numbers because you have to exclude your denominator equal to 0. So it's all real numbers, but you have to exclude so for the domain in this case, it's going to be that you're going to exclude x minus 3 equal to 0, which if we add the 3 back over, that means we're going to exclude x equals 3. So what you can do for that one is we can still do the funky r, but then just give me a comma and say that x cannot equal 3. And that would be okay for the domain there. So it's all real numbers except for as long as we skip 3, everything else is fair game. All right, so let's do this. Let's give you one where, well, let's do the same thing again. Let me give you a different f of x and g of x, and then we'll work through and do all the same things we just got through doing there, so we can make sure everybody's okay with it. All right, so for this one, let's give you f of x equals 3x squared minus 11x minus 4. And g of x is x minus 4.
So every time we get a function, or every time we get an improving number, we have to do all 4 of them?
In this case, we're going to skip the addition because addition is going to be fairly straightforward. So for this one, we're going to actually start with, let's start with subtraction. Let's do f of x minus g of x. All right, so that's 3x squared minus 11x minus 4. And when we do subtraction in this case, the big thing is that it's minus the whole g of x. So if you want to put addition here, or sorry, if you want to put parentheses there, you can. But really, it's the second one that you have to worry about. Addition or subtraction, you don't really have to have parentheses here. But I guess if you want to go ahead and think about it that way for all of them, you can go ahead and do it that way.
Why did we skip addition?
Because it's just the only difference between addition and subtraction is with addition, we would make this a plus and we don't have to worry about changing any signs of any kind. So subtraction will be basically the same thing. It's just we got to make sure we change that sign. Cutting out a little bit of repetition, basically, is what we're doing. Okay, so that's going to be 3x squared minus 11x minus 4 minus x plus 4. All right, so that's 3x squared. We've got minus 11x and minus basically 1x, so that would be a minus 12x. We've got a negative 4 plus 4, so those are going to cancel. So in that case,
Should we not pull out the greatest common factor? Should we not pull out?
you could take out greatest common factor in this case. Probably more than likely, if they said factor completely, then you would. But for this one, you probably don't have to worry about it because you're just combining like terms.
Okay.
All right, again, if they ask for domain, all real numbers. All right. Oh, multiplication would actually be a good one to do on this one also. So let's do some multiplication. Let's do f times g of x. Okay, so multiplication, you could do it this way. Now, but what we're going to do, just to make it so it doesn't, because this is going to be one of those, if you go back and do all the multiplication on this thing, it's going to stretch out and be kind of long. So for this one, how about we just stack this thing up? And we're going to multiply it this way. We're going to do it like the old-fashioned way. Yeah. Yeah, if you want to do it the regular way, you can, but this would actually make it a little bit easier because we're going to start with negative 4 times negative 4, which would be a positive 16. A negative 4 times a negative 11, which would be a positive 44x. And then negative 4 times positive 3, which would be negative 12x squared. Okay, and then we're going to do the same thing with x. And remember that when you're doing multiplication, like with the big multiplication, how you'd always kind of put a space holder here. Basically, you put a 0 here for like a space holder. And then we're going to do x times negative 4, which is negative 4x. We'll do x times negative 11x, which is negative 11x squared. And then x times 3x squared, which would be 3x to the third. Okay, and the big advantage to doing it that way is, what do you notice about all your terms? Yeah, they're all in order. They're all stacked up. So when you start combining your like terms, you don't have to bounce from here to here and there to there and this back and forth. Everything is lined up at 16 and 0, which is basically 16. It was positive. We've got 44 minus 4. That's a positive 40x. It's negative 12, negative 11. That's negative 23x squared. Then we got just the 3x to the third in front. And there you go. It's all nice and neat. And you don't have to worry about, bouncing around. And you don't have arrows and loops and stuff going everywhere. It's just all kind of stacked up and kind of neat. So to me, anytime you've got something that you're going to do the full method and there's actually, 3 terms and not 2 terms, it actually kind of benefits you if you can get used to seeing it this way. Now, sometimes it takes a time or two before you get comfortable with it, but it does kind of help to get this answer kind of stacked up a little bit nicer and neater there. Okay, any fractions, any square roots? Nope. So in that case, domain is all real numbers. All right, so for division, we're doing f divided by g. That is 3x squared minus 11x minus 4 over x minus 4. Okay, and again, just fight the temptation because sometimes people go, oh, I'll cancel out my -4s and I'll cancel out my 11s, and I've got 3x squared minus 11. That's my answer. Remember, in this case, you've got to factor, which means the denominator is fine because there's nothing you can factor there. But the top part, oh, what we got to do here? First term is 3, right? So we're going to have to do the AC method. So you're going to have to do 3 times -4. Oh, yeah. So see, good review here. 3 times -4, so it's the factors of -12, where the sum is going to equal -11. All right. Could be 1 and 12. Yeah. Definitely cannot be 3 and 6. Definitely cannot be 3 and 4. So it's got to be 1 and 12. Yeah. There we go. B term is negative, so the bigger number has to be negative. If you divide a negative and negative, it makes the 1a positive. So good factoring review. All right, so that'll leave us with x plus 1 and x minus 12. Now, what's the one catch, though? We're not done there, right? Got one more step. So in the beginning, we weren't just doing the factors of 4. We had to multiply by 3, correct? Yeah, there we go. So we got to go back and divide it by 3. All right, so that's x minus 4. That doesn't simplify, right? So we get to do the bottoms up, take the bottom number, pull it up in front of x, and make it 3x plus 1. And then we put that over x minus 4. So we got that. Okay, which means the x minus 4 is cancel, which means our final answer is 3x plus 1. All right, now, even though we canceled out the -4s, or we canceled out the x minus 4s, when they talk about the domain, you still go back to the original problem. So the domain is basically going to be all real numbers. But again, we have to exclude the original denominator equal to 0. So that means we got to exclude x equals 4. So it's going to be all real numbers except for x cannot equal 4 for the domain. Okay. All right, so let's give you, let's see. This will be kind of a good review, I think, in a way. We'll do one more. We'll go through the options, and then this will wrap us up for today. Well, we do have like 3 parts to each example, so, Okay, so for f of x, let's go with 2 minus x, and g of x is 1 over x.
Yeah, no, we definitely need that online test.
All right, so for this one, we won't do all of them. We'll do, let's do addition in this case. So if we do f plus g That's 2 minus x plus 1 over x. Okay, now in this case, probably what we're going to do, and this is, I don't know, we actually talked about this. I think this is one of those things that kind of got skipped, but it's kind of good to throw this in here because if you're going into pre-cal, they will probably make you do this at some point in time. So it's kind of good that we throw this in here. When you've got combining like terms and you're going through this expression, a lot of times they will tell you if you get this answer, they do not like for an answer to have a fraction. Kind of like when we rationalize. And now it's okay if you've got a number and you got like a denominator, it's a number. But if you've got an x in the denominator, a lot of times they don't like that to be there. So what we're going to do is we're going to eliminate variable denominators. Probably what they would tell you to do in the question. So eliminate variable denominators. Or they would tell you that make sure that your denominators do not have any variables. All right, so if that's the case, then all you have to do is just multiply by the least common denominator. Which in most cases is going to be really pretty easy because what's the only thing in our denominator? It's x, right? So we're going to take every single term that's here and we're just going to multiply by x. So it's x times 2, x times x, and x times 1 over x. So if we do that, we've got 2x minus x squared plus 1. And in that case, we'll kind of go back to the old thing of writing it in standard form. So let's make it negative x squared plus 2x plus 1. Well, now again, we're going back to the original. So if we go back to the original part of this one, when we talk about the domain, that in the very beginning back up here, we had this is our problem, that we've got to exclude x equals 0. And the good news is that when you do that, it's already solved. So basically, when we talk about the domain, it's going to be all real numbers. But x cannot equal 0. So there's our answer, and then there's our domain. Oh, because most of the time it was like x plus 2 equals 0 or something in that case. So in this case, it's just x equals 0 because this was our one denominator we had. So if we just set that equal to 0, there's nothing to add or subtract away from it. So it's just x equals 0. Okay, multiplication will be really kind of similar. Now subtraction, the only thing that's going to change with subtraction is it's just going to be minus that. So it would just change that one sign, and other than that, the rest of the answer would be the same. So, yeah, so in that case, we're going to skip subtraction because if you do subtraction, you're just going to change this to a minus, and that's the only difference in the answer. The denominator is the same, the exclusions are the same, so everything on that part is the same, just that one thing that's different there. All right, multiplication. We're doing 2 minus x times 1 over x. And in that case, it's not full method, it's just distributive property. So it's 2 times 1 over x, and then 1 over x times x, which would just make that a minus 1. All right, and again, they do not like, in this case, they'd probably tell you do not leave x in the denominator. Basically, we're going to rationalize it here. So what we're going to do then is we're going to take that answer and then multiply by x to make it 2 minus x. Now, and again, unless they say put it in standard form, if they say standard form, you've got to put the x first and then the 2 second. And again, back in the original, we still have this x in the denominator, so it's still going to be the same thing. That's all real numbers, but x cannot equal 0.
We're done.
All right, and one more. Got to do division. All right, because with division, it looks funny, right? Because you got a fraction inside a fraction. Okay, so what we're going to do is we're going to go back to like 7th grade, 8th grade math here. Because if you got a fraction here, we're going to keep it, we're going to change it, and we're going to flip it. So that's really 2 minus x times x over 1, which is just x. But again, the 1 doesn't really help us out in that case, so really it's just distribute property with the x. So that's 2x minus x squared. And again, that answer is okay, but if they ask for you to rewrite it in standard form, it'll be that. And we still have this x in the denominator that was here. Even though it's in the denominator, it's still only x is in the denominator. So when they ask for your domain, it's all real numbers except for x cannot equal 0.